Welcome back to Statistics Made Simple, and I'm Savita Valsam. I really hope that all those who wrote the second PUC statistics exam found the paper really easy. So I'm solving the paper in this video, and you can verify your answers. Section A, first mean, choose the most appropriate answer from the choices given. 5 into 1 is equal to 5. The births occurring to women of childbearing age is called fertility, mortality, survival ratio, fecundity. The correct answer is fertility. Second question, the prices of index numbers decreased by 10% in 2024 as compared to 2020. The index number for the year 2024 is 10, 90, 100, 110. So the correct answer is 90. The parameter of a t distribution is n equal to 10, then the mean is 0, 5, 10 and 20. So we know that the mean of the t distribution is 0. So the correct answer is A, 0. Fourth question, the standard error of the sample proportion is PQ by N, P by N, root PQ by N and Q by N. The correct answer is root PQ by N. Fifth question, a game is said to be fair if the value of the game is not equal to 0, is equal to 1, is equal to 2, is equal to 0. The correct answer is D, V is equal to 0. Second mean, fill in the blanks by choosing the appropriate answers given in the brackets. 5 into 1 is equal to 5. Sixth question, the value of the index number for the base year is 100. Seventh question, in the dash distribution, variance and standard deviation are equal. The answer is standard normal. Eighth one, a statistical constant of a population is called as a parameter. Ninth one, an item having one or more defects is called a defective item. And 10th one, the equipment is replaced at the end of a year for which the annual average cost is minimum. Third mean, match the following. 5 into 1 is equal to 5. The 11th question, NRR per woman is equal to 1. It indicates that the population has increased. So population has increased. The base year weight is Laspeyer's price index number has the base year weight as the quantity. The mean of a t distribution is 0. Single value proposed as an estimate is point estimation. And physical stock of goods is the inventory. Fourth main, answer the following questions. 5 into 1 is equal to 5. Define fecundity. The capacity of women to bear children is termed as fecundity. So let's write the sentence. The capacity of women to bear children is termed as or is called as fecundity. Mention 13th question, mention a cause of irregular variation in time series. So a cause, it can be like floods, it can be fire, it can be strikes, it can be tsunami, or it can be famines, lockouts, etc. 14th question, for what value of P binomial distribution is symmetrical? So when P is equal to 0.5, P is the probability of success. In that case, binomial distribution is symmetric. 15th question, define level of significance. The maximum size of the test is the level of significance and it is also denoted by alpha. 16th question, in graphical method, why feasible solution of linear programming problem lies in the first quadrant? This is because of the non-negativity restriction, which states that x and y should be greater than or equal to 0. Section B, fifth main, answer any 5 of the following questions. 5 into 2 is equal to 10. 17th question, write 4 stages of business cycle. First one is prosperity. The second one is recession. Third is depression. And fourth is recovery. 18th question, write the conditions for applying binomial expansion method of interpolation and extrapolation. The first condition is that the x values should be equally spaced. Second is the values of y which have to be estimated should be corresponding to the values of x in the given data. 19th question, if P is equal to half for a Bernoulli distribution, find the mean and variance. So first let us write the information which is given. So we know that P is called as the probability of success. So write given P is equal to half, which is equal to 0.5. Q is equal to 1 minus P. 1 minus 0.5 is equal to 0.5. Now first let us write the formula for the mean. So consider expectation of x is equal to P, which is equal to 0.5, and B, you write the formula for the variance. So consider V of x is equal to PQ, which is 0.5 into 0.5. So the answer is 0.25. 20th question, mention the 2 features of the Poisson distribution. So if you refer to my video on the Poisson distribution, you can get about 12 or more properties. And here I've listed down about 6 of them. You can write any 2. The first one is the mean is lambda. The variance is lambda. The standard deviation of the Poisson distribution is SD of x is equal to root lambda. And the mean is equal to the variance for the Poisson distribution. And when lambda is not an integer, the Poisson distribution is unimodal and the mode is the integral part of lambda. And whenever lambda is an integer, then the Poisson distribution is bimodal and the 2 modes are lambda minus 1 and lambda. 21st question, define type 1 and type 2 errors. So what is type 1 error? So type 1 error is rejecting H0 when H0 is true. So type 1 error is you reject H0 when H0 is true. So H0 is the null hypothesis. And type 2 error is you accept H0 when H0 is false. 22nd question. In a pair T test, if n is equal to 5, d bar is equal to 3.4 and sd is equal to 2, then what would be the value of the test statistic? So let us consider the test statistic for the pair T test, that is, consider T equal to, it is d bar divided by sd by root n minus 1, which we know follows Tn minus 1. So which implies T is equal to 3.4 divided by 2, which is divided by 5 minus 1, 5 minus 1, which is equal to 3.4 divided by 2 by root 4. This is 3.4 divided by 2 by 2. 2 and 2 will get cancelled. So we get T is equal to 3.4. 23rd question. Mention two types of causes of variation in a manufacturing process. This question is from SQC, that is Statistical Quality Control. The first one is the chance causes of variation, and second are the assignable causes of variation. Twenty-fourth question. Given R is equal to 5000 units per year, C1 is equal to rupees 2 per unit per year and C3 is rupees 200 per cycle, find Q to the power 0. So let's write the formula for EOQ, that is Q to the power 0. This is for the inventory model without shortages. So it is root of 2R C3 divided by C1, which is equal to root 2 into 5000 into 200 divided by 2. So 2 and 2 will get cancelled. So it is root of so you'll get Q to the power 0 is equal to 1000 units. Section C, the sixth main, answer any four of the following questions. 4 into 5 is equal to 20. 25th question, calculate consumer price index number by aggregative expenditure method. They have given us the commodities A, B, C, D and its prices in 2019, which is the base year, and 2024, which is the current year, and the quantity in the base year 2019 are also given. So let us start the problem. First, let us write the formula. So write consider. So CPI, the aggregative expenditure method, is similar to last year's price index number. So the formula is summation P1 Q0 divided by summation P0 Q0 into 100. So let us do the calculations in the table now. So first, price in 2019, you mark it as P0. The price in 2024, mark it as P1. The quantity in 2019, mark it as Q0. So first, let us find out P1 Q0. So 8 into 20 is 160. Next is 480. Then 800 and 2000. Similarly, let us find out P0 Q0. So it's 4 into 20 is 80. Next is 400, 600, 1250. So find out summation P1 Q0, which is 3440, and similarly find out summation P0 Q0, which is 2330. So now let us substitute these totals in the formula. So you will get 3440 divided by 2330 into 100. So therefore CPI is equal to 147.64. 26th question. Interpolate and extrapolate the profit for the years 2019 and 2025 by using binomial expansion method for the following data. The years are given from 2015 to 2025 with a difference of 2 years along with the corresponding profit in rupees for these years. Now the first step is to mark year as X and the profit as Y. Next mark 8 as Y0, 14 as Y1, next Y2, Y3, Y4 and Y5. So now the first step is to write the number of known values of Y. So let us start the problem. Write given number of known values of Y. That is, so if you count, the number of known values of Y are 1, 2, 3, 4. So that is n is equal to 4. Then write the formula for the binomial expansion method. Consider y minus 1 to the power n is equal to 0, which implies y minus 1 to the power 4 is equal to 0. Now how do you expand y minus 1 to the power 4 equal to 0? Start with the power. So it is y4, leave some space, y3, then y2, y1, y0 equal to 0. The first coefficient of y4 will have the plus sign. So here it is plus, next is minus, plus, minus, plus. So it's alternating plus, minus, plus, minus, plus. Now what you see here at this side is the Pascal's triangle. So Pascal's triangle will help us to find the coefficients of this binomial expansion. So because n is equal to 4, if you observe, the coefficients are 1, 4, 6, 4 and 1. So here we have 1, next you write 4, then 6, 4 and 1. So whether we write 1 or not, it doesn't matter. Now see the table and substitute the values. So it is 30 minus 4 into 21 plus 6 y2 minus 4 into, it is 14, 4 into 14 plus 8 is equal to 0. Now just leave 6y2 as it is along with the sign. So which implies 30 minus 84 plus 6y2 minus 56 plus 8 is equal to 0. So again keep plus 6y2 as it is. So put the remaining values in a calculator, that is 30 minus 84 minus 56 plus 8. So you'll get minus 102. So which implies 6y2 minus 102 is equal to 0, or which implies y2 is equal to 102 divided by 6. So which is equal to 17. So you can write, therefore the profit for the year 2019 is rupees 17. Now next is to increase the suffix of y by 1. So when we increase the suffix of y by 1, we get, so in this particular equation you should increase only the subscripts. So you will get y5 minus 4y4 plus 6y3 minus 4y2 plus y1 is equal to 0. Now substitute the values from the given table. So it is y5 minus 4 into 30 plus 6 into 21 minus 4 into 17 plus 14 is equal to 0. Now just keep only y5 as it is. So y5 minus 120 plus 126 minus 68 plus 14 is equal to 0. So which implies y5. Now in the calculator you have to type in minus 120 plus 126 minus 68 plus 14 is equal to 0. So you'll get y5 minus 48 is equal to 0, which implies y5 is equal to 48. So you can write, therefore the profit for 2025 is rupees 48. Twenty-seventh question. The probability of an arrow hitting a tree is 1 by 4. If 3 arrows are aimed at the tree, find the probability that first subdivision no arrow hits the tree, second 2 arrows hit the tree. So now this is based on the binomial distribution. So because it's a binomial distribution, you need the two parameters n and p. N should be a whole number and p can be either in percentage, decimals or fraction. So let us start the problem. So first write given. So probability of hitting a target is considered to be a success. So the probability of success is p. So p is 1 by 4, means it is 0.25. Then find out q, which is 1 minus p. 1 minus 0.25 is equal to 0.75. And if 3 arrows are aimed at the tree, means n is equal to 3. Next, you define capital X, that is number of arrows that hit the tree. The next step is to write the PMF. So write PMF. P of x is equal to, open the flower bracket, it is NCX. So 3CX, P to the power x, so 0.25 to the power x, Q to the power n minus x, so 0.75 to the power 3 minus x, where x takes value 0, 1, 2, 3. Is 0 otherwise. So actually x takes values from 0 to n. Here n is 3, so we stop at 3. Now start with the first subdivision. So first subdivision is find the probability that no arrow hits the tree. So consider probability of no arrow hits the tree means probability of x equal to 0, which is p of 0, which is equal to 3c0, 0.25 to the power 0, 0.75 to the power 3 minus 0. So 3c0 is 1, 0.25 to the power 0 is 1, and 0.75 to the power 3 is 0.4219. So the first answer, probability of x equal to 0 is 0.4219. Now we do the second subdivision. 2 arrows hit the tree. So consider probability of capital X equal to 2, which is equal to P of 2, which is 3C2, 0.25 to the power 2, 0.75 to the power 3 minus 2. So 3C2 is 3. Then 0.25 to the power 2 is 0.0625 and 0.75 to the power 1 will be 0.75. So therefore probability of x equal to 2 is 0.1406. 28th question. A basket has 10 mangoes, of which 6 are ripe. 3 mangoes are randomly selected from the basket. Find the mean and variance of the number of ripe mangoes. So if you have practiced a lot of problems on distribution, you will realize that this problem is based on the hypergeometric distribution. So here A will be the number of ripe mangoes and B will be the number of unripe mangoes, and the total number of mangoes in the basket is 10. So let us start the problem. So first you write given. The total number of mangoes in the basket is 10, means A plus B is equal to 10, and 6 are ripe. So A stands for the number of ripe mangoes. So this is equal to 6. So B will be equal to 10 minus A, which is 10 minus 6, which is equal to 4. And then they have also said 3 mangoes are randomly selected. That means N is equal to 3. So start with the first subdivision. Write the formula for the mean of the hypergeometric distribution. So consider E of X is equal to NA divided by A plus B. So this is equal to 3 into 6 divided by 10. So you will get 18 divided by 10. So expectation of X is equal to 1.8. Now let us move to the second subdivision. So what is the second subdivision? They have asked us to find out the variance of the number of ripe mangoes. So let me write the formula for the number of ripe mangoes. Consider variance of X is equal to NAB into A plus B minus N divided by A plus B the whole square into A plus B minus 1. So this is equal to 3 into 6 into 4 divide into A plus B is 10. So 10 minus 3 divided by A plus B whole square is 10 square into 10 minus 1. So if we multiply, we get 72 into 7 divided by 100 into 9, which is 504 divided by 900. So therefore we get variance of X as 0.56. 29th question. The standard deviation of production of wheat is assumed to be 10.2. A sample of 25 acres showed that the standard deviation is 8.2. Test at 1% level of significance whether the standard deviation of the production of wheat is less than 10.2. So if you observe the question, you have the word standard deviation, which is mentioned in the whole question. So this particular test is based on the chi-square test for the population variance. But here instead of population variance, the population standard deviation is given. So we need to get 3 values from the question. So the first sentence doesn't have the word sample. So standard deviation of the population means it is denoted by sigma naught, which is 10.2. A sample of 25 acres means n is 25, and the standard deviation of the sample means it is s square is equal to 8.2, and then they have mentioned that alpha is equal to 1%. Now in the question also observe that they have used the word less than. So less than will be considered when we write the alternative hypothesis. So let's now continue with the problem. So H naught. So the format is H naught. The population standard deviation is sigma naught. So we can just write sigma is equal to 10.2. So versus H1, sigma is less than 10.2. Then let's write the test statistic. So under H naught, the test statistic is, so it is chi-square is equal to ns square by sigma naught square, which follows chi square n minus 1. So this is equal to n is 25, s square. I'm sorry, here let me make a small change. This should be only s, because I've used the word standard deviation, it will be only s. I'm sorry for that mistake which I made. Let me continue with the problem now. So s squared means it is 8.2 the whole square divided by 10.2 the whole square. So let us continue. So chi square is equal to 25. 8.2 the whole square is 67.24 and 10.2 the whole square is 104.04. So we get chi square is equal to 16.1572. Now let us write the condition for the chi square test for a left-tailed alternative. So a left-tailed alternative, the condition is chi square is less than or equal to k1, then we reject h0. So now let us write the degrees of freedom. Degrees of freedom is n minus 1. So 25 minus 1 is equal to 24. So at 1% level of significance for 24 degrees of freedom, we have K1 is equal to, it is 10.9. So next write the conclusion. So since chi square equal to 16.1572 is not less than K1 equal to 10.9 at 1% level of significance for 24 degrees of freedom, we accept H0 and conclude that sigma is equal to 10.2. 30th question, find an initial basic feasible solution for the following transportation problem by northwest corner rule method and compute the total transportation cost. So they have given the three origins O1, O2, O3 along with the demand, and then you have the destinations as D1, D2, D3, D4, and they have given us the supply, which is nothing but the availabilities. So now the first step is to mark 300 as A1, 500 as A2, and this is A3. Then the demand are the requirements. This is B1, this is B2, B3 and B4. So when we add up the AIs and when we add up the BJs, we get 1400. So it is a balanced transportation problem. So let us start with the first allocation. So let's start with the first allocation in the cell 1, 1. So x11 is minimum of, it is A1, comma B1, which is minimum of 300, comma 75, which is equal to 75. So we write the allocation here as 75. Now to check whether 75 is matching with the availability or it's matching with the requirement. It is matching with the requirement at D1. So we move to the right and then the formula is x is equal to, it is minimum of A minus x comma B. So we came to this cell. This cell is x12. 1 subscript you write it for A, 2 subscript you write it for B, and the x will be the previous allocation, that is x11. So this is minimum of A1 is 300 minus 75, comma 325. So this is equal to minimum of, it is 225 minus 325. So you will get the minimum value as 225. So now you write 225 here in the small cell. So 225 doesn't match with 300, 225 doesn't match with 325. But in this row, when you add 225 and 75, you get 300, which matches with the availability at O1. So because availability is satisfied, now you have to move vertically down. So you have come to this cell. So whenever availability is satisfied, the formula which we use is X is minimum of A comma B minus X. So this particular cell is 2, 2. So X22 is equal to minimum of A2, B2 and the previous allocation X12. So this is equal to minimum of A2 is 500, comma 325 minus 225. So you will get minimum of 500 comma 325 minus 225 will be 100. So you will get X22 is equal to 100. So next you write the allocation here as 100. So 100 doesn't match with 500, 100 doesn't match with 325. But in this column, when you add 225 and 100, you get 325, which matches with the requirement at D2. So whenever requirement is satisfied, you should move to the right. And what is the formula you'll use now? X is equal to minimum of, it is A minus X comma B. So you came to this cell is 2, 3. So X23 is minimum of A2 and then B3, and X will be the previous allocation X22. So this is minimum of A2 is 500 minus 100 comma B3 is 500. So this is minimum of, it is 400 comma 500. The minimum value is 400. So write 400 over here. So 400 doesn't match with 500, 400 doesn't match with this 500, but in this particular row, when you add 400 plus 100, it is 500, which matches with the availability at O2. Now because availability is satisfied, you move vertically down. So the formula is X is equal to minimum of A comma B minus A comma B minus X. So this particular cell is 3, 3. So X33 is equal to minimum of A3 comma B3 minus X23. So this is minimum of A3 is 600 comma B3 is 500 minus 400. So minimum of 600 comma 100 will be 100. So now write 100 here. 100 doesn't match with 600, 100 doesn't match with 500. But in this column, when you add 400 plus 100, you will get 500, which matches with the requirement at D3. So because requirement is satisfied, you move to the last cell here, that is 3, 4. And because requirement is satisfied, use the formula X34 is equal to minimum of, it is A minus X comma B. So it will be A3 minus X33 comma B4, which is equal to minimum of 600 minus 100 comma 500. So you will get minimum of 500 comma 500, so which is equal to 500. So if you see, 500 matches with the requirement at D4 and 500 plus 100 gives you 600, which matches with the availability at O3. So therefore, the initial basic feasible solution is X11 is 75, X12 is 225, X22 is 100. then x23 is equal to 400, x33 is equal to 100, x34 is equal to 500. So therefore, the total transportation cost is Z equal to 75 into 25 plus 225 into 17 plus 100 into 10 plus 400 into 18 plus 100 into 8 plus 500 into 13. So you'll get rupees 21,200. 31st question. The purchase price of a machine is rupees 8,000. Its maintenance cost and resale values are given below. So they have given us the different years and they have given the maintenance cost and the resale values for these years. So first let us mark year as N. The maintenance cost is CI and resale value is SN. So now let us start the problem. So first we will write the annual average cost formula. So you can write consider the annual average cost so the formula is AN is equal to P minus SN plus summation CI divided by N. So now in this question, they have given to us the purchase cost. So the purchase cost is denoted by capital P, which is equal to 8,000. So now let us form all the columns which are required in the formula in the table. So first you will require P minus Sn, then you will require summation Ci, then P minus Sn plus summation Ci, and in the last column you will need An. So P minus Sn means 8,000 minus 4,500 is 3,500. Similarly, 8,000 minus 3,500 is 4,500. Then we have 5,500, 6,500 and 7,000. Next, find out summation Ci. So first write 500. So summation Ci means the cumulative maintenance cost. Next is 500 plus 600 is 1,100. Then you'll get 1,900. Then 3,000 and 4,500. The next column is P minus Sn plus summation Ci. So just add the previous two columns. So here you will get 4,000. Next is 5,600. Then 7,400, 9,500 and 12,000. An will be 4,000 divided by 1 is 4,000. Next is 5,600 divided by 2 is 2,800. 7,400 divided by 3. So it is 2466.67. Then 9,500 divided by 4, which is 2,375. And then 12,000 divided by 5 is 2,400. So now you have to see the An column and see where it decreases and then finally it is increasing. So you will observe that it decreases till 2,375 and then immediately increases. So our conclusion will be when we have to replace the machine. So conclusion, the machine should be replaced at the end of the fourth year and the minimum annual average cost is rupees 2375. 32nd question. The weekly wages of workers are normally distributed with mean rupees 3000 and standard deviation rupees 500. Calculate the probability of workers whose weekly wages will be first less than rupees 3500, second between rupees 2500 and rupees 3500. So let us start the problem. We will write given. Mean means mu, that is 3000. Standard deviation is sigma, that is equal to 500. Next, define X as weekly wages of workers. So you can write that is X follows normal 3000, 500 square. Then write the formula. We know that Z is equal to X minus mu divided by sigma, which follows normal 0, 1. So now let us continue with the first subdivision. So start the first subdivision, write consider. It is probability of X less than 3500. As we know that the standard normal tables is given in terms of Z, we have to standardize. So standardize means from X subtract mu divide by sigma is less than 3500 minus mu divided by sigma. So this is equal to probability of X minus mu by sigma is Z is less than 3500 minus 3000 divided by 500. So you will get probability of Z less than 500 by 500 is 1. So next you draw the standard normal curve. The center line is Z equal to 0. Then here you have minus infinity and infinity. Then this number here is 1. It is positive, so mark it on the right tail. And less than 1 means you should shade to the left of the number 1. So shade from 1 to minus infinity. So this is equal to area from 1 to minus infinity. But we cannot find out the area from 1 to minus infinity in the table. So you have to change the sign throughout and it becomes area from minus 1 to infinity. This is because the normal distribution is symmetric. So when you find out the answer, you will get it as 0.8413. Now the second subdivision between 2500 and 3500. So consider probability of 2500 is less than X is less than 3500. So this is equal to probability of, again you have to standardize. So 2500 minus mu by sigma is less than X minus mu by sigma is less than 3500 minus mu divided by sigma. So this is equal to probability of 2500 minus 3500 divided by 500 is less than Z is less than 3500 minus, this is 3000 minus 3000 divided by 500. So this is equal to probability of 2500 minus 3000 will be 500 by 500 is 1 is less than Z is less than, this is minus 1 is less than Z is less than 1. So again you draw the standard normal curve. So this is Z equal to 0, then minus infinity and infinity. z equal to -1 is negative, so mark it on the left tail. Then z equal to 1 is positive, mark it on the right tail. Z lies between these two numbers, so you have to shade between those two numbers. So this becomes area from -1 to 1. But remember that you can find out the area from only any number to infinity. So from the starting point of the shading till infinity, draw a curve and bracket, and then from the ending point of the shading to infinity, draw another bracket. So the larger flower bracket minus the smaller flower bracket area will give the shaded area. So this is equal to area from -1 to infinity minus the area from 1 to infinity. So the area from -1 to infinity we already know is 0.8413 minus 0.1587. So you get 0.6826. 33rd question. For the following data test whether the means differ significantly, use alpha equal to 0.01. So because you have two samples and they've used the word means, it is test for equality of means. Next is to see the sizes n1 and n2, they are greater than 30. So it is large sample test for equality of means. So you have to write down 6 values which are given along with the level of significance. So first write given. So size they are mentioned. So n1 is equal to 80, n2 is equal to 40. Then the means of the sample means x bar 1 is 54, then x bar 2 is 52. Variance of the sample. So s1 square is equal to 16, s2 square is equal to 25, and alpha is equal to 1%. So H0 will be the two population means are equal, or you can just write mu1 is equal to mu2 versus H1. It is a two-tailed test, so versus H1 mu1 is not equal to mu2. Then write the test statistic. So under H0, the test statistic is So the formula is z equal to x bar 1 minus x bar 2 divided by root of it is s1 squared by n1 plus s2 squared divided by n2, which follows normal 0, 1. So you will get after substitution z is equal to 54 minus 52 divided by root. Now s1 square, we already have the squared values. So it is 16 by 80 plus 25 divided by 40. So this is 2 divided by, next find out 16 divided by 80, that is 0.2 plus 0.625. So this is equal to 2 divided by 0.825, or this is 2 divided by 0.9083. So you will get z is equal to 2.201. Now because it is large sample test and the alternative is two-tailed, the condition is mod z is greater than or equal to k alpha by 2, in which case you will reject H0. So this is the condition for a two-tailed test. So which implies modulus of z is modulus of 2.2019, which will remain as 2.2019. So next you have to find out k alpha by 2 at 1% level of significance. At 1% level of significance, we have k alpha by 2 is equal to 2.58. Then let us write the last part, that is the conclusion. You have to compare mod z with k alpha by 2. So since modulus of z is 2.2019, you have to check whether it is greater than 2.58. So it is not greater than k alpha by 2 equal to 2.58 at 1% level of significance. So we accept H naught and conclude that mu1 is equal to mu2. The 34th question. In a floor mat manufacturing company, the average number of defects per square meter is known to be lambda dash is equal to 4. Determine the control limits for the number of defects per square meter. So because of the word defects, it is the C chart. So let us start the problem. So you can write C chart, case, when the process standard is known. In this case, it is the lambda value. It is already known to us. So I'll write here given lambda dash is equal to 4. So next sentence you can write the 3 sigma control limits are, so CL is equal to lambda dash, UCL is equal to lambda dash plus 3 times root lambda dash, and LCL is equal to lambda dash minus 3 times root lambda dash. So substitute, so you'll get therefore CL is equal to 4, UCL is equal to 4 plus 3 times root of 4, which is 4 plus 3 into 2. So 3 into 2 is 6, 6 plus 4 is 10, and LCL is equal to 4 minus 3 times root of 4, which is 4 minus 3 into 2. So this is 4 minus 6 is equal to minus 2 is approximately equal to 0. So therefore CL is 4, UCL is 10, and LCL is approximately equal to 0. So these are the final 3 sigma control limits. Section E, minimize z equal to 2x plus 3y subject to x plus y greater than or equal to 350, 2x plus y less than or equal to 600, and x comma y greater than or equal to 0. So start the problem. Write step 1. Convert inequalities to equalities. So x plus y is equal to 350, 2x plus y is equal to 600. Step 2. To obtain the points of the two lines. Then step 3. So take the first equation, consider x plus y is equal to 350. Put x equal to 0, so you'll get y is equal to 350, and put y equal to 0, so you'll get x equal to 350. So 0 comma 350 and 350 comma 0 are the points of the two lines. Then take the next equation, consider 2x plus y is equal to 600. Put x equal to 0, so y is equal to 600, and put y equal to 0. So you'll get 2x is equal to 600, which implies x is equal to 600 divided by 2, which is equal to 300. So the points are 0, 600 and 300, 0. Then we move to step 3, that is to draw the graph. So I've drawn the graph above. So now on the x-axis, I have taken the values as 0, 50, 100, 150, 200, 250, 300, 350, and on the y-axis, I have taken 100, 200, 300, 400, 500 and 600. So scale x-axis 1 centimeter is equal to, it's not clear over here, so actually it is 50 units. So I have taken 1 centimeter is equal to 50 units for the x-axis, and for the y-axis I have taken 1 centimeter is equal to 100 units. So now mark the first point, that is 0, 350. This is 0 and 350 is the exact middle of 300 and 400, that is here. And then you mark 350, 0. So on the x-axis, here you have 350, so it's 350, 0. So then join the points 0, 350 and 350, 0 by a straight line, and on that line you write x plus y is equal to 350. Then take the next 2 points 0, 600, so that is here, and 300, 0 is here. Join these 2 points by a straight line, and on that line you write 2x plus y is equal to 600. Then you move on to step 4 to obtain the feasible region. So to obtain the feasible region, you should take the inequalities. So consider the first inequality, x plus y greater than or equal to 350. Put x equal to 0, y equal to 0. So you'll get 0, and then here you have 350. Check whether 0 is greater than 350. It is not greater. So you will write false. Then take the other inequality, that is 2x plus y is less or equal to 600. So put x equal to 0, y equal to 0. So you have 0 and then 600. Check whether 0 is less than 600. It is less than 600. So you'll write true. So for the first equation it is false, and the second equation the condition is true. So this is the first equation, that is x plus y equal to 350. So it is false. So you have to shade away from the origin. So I have used the blue color, that is I have shaded on top of the line. Then the other equation is 2x plus y equal to 600, that is this line. For this it is true, so I have shaded towards the origin, that is I have used a red color line. Now what you have to do is, it is a minimization problem. For a minimization problem you can have an open figure or a closed figure and still you will have the solution. So now find out where the two types of shading are meeting. So if you observe carefully, this is the area where the two types of shading are meeting. So mark this as A, 0, 600. This as B, that is 0, 350, and this point here is C. So from this point you draw a perpendicular to the x-axis. So it will touch the x-axis at 250, and from this point draw a line parallel to the x-axis. It is touching the y-axis at 100. So C, the points are 250, 100. So step 5 is you have to write the corner points of the common feasible region. So now let us write the corner points. So step 5, the corner points. So the corner points are A 0, 600. Then you have B 0, 350. C is 250, 100. Then step 6 is to evaluate Z at the corner points. So you consider minimize Z equal to 2x plus 3y. So ZA is equal to 2 into 0 plus 3 into 600 is 1800. Then ZB is 2 into 0 plus 3 into 350, which is 1050, and ZC is 2 into 250 plus 3 into 100. So this is 500 plus 500 plus 300. It is equal to 800. Now because it is a minimization problem, find out the least value here. So the least value is 800. So you can write the conclusion. The given LPP has an optimal solution at C 250, 100 and minimum Z is equal to 800. Section D, the 8th main, answer any two of the following questions. 2 into 10 is equal to 20. 36 question, from the following data compute standardized death rates for village A and village B. Which village is more healthy? So they have given us the age groups and village A's population and deaths, village B's population and deaths, and the standard population. So the first step is to mark the standard population as capital P and then find out the total of the standard population. So you get summation P is equal to 30,000. So now let us start the problem. First I will write locality, it will be village A. So let me write village A. Write the formula. Consider STDR of A is equal to summation PA divided by summation P. Now we should write the formula for A. So A stands for ASDR. So I'll write the formula here. So ASDR is equal to number of deaths in a specific age group divided by, it is the average population in a specific age group into 1000. So this carries 1 mark. So now what we have to do is we have to calculate ASDRs for village A and village B, and later I'll write the formula for STDR of B, which is summation PB by summation P. So now let us form here the column ASDRs. This is for village A and this is for village B. So it is 68 divided by 4000 into 1000. So we do the calculations. So you will get 17. The next one is 6. Then you get 13 and 43. Similarly, ASDRs for village B is 160 by 8000 into 1000 will be 20. Then you have 5, 10 and 40. So next we have to find out PA and PB. So it will be 17 into 6000 is 1,02,000. The next one is 72,000, then 1,04,000 and 1,72,000. So you'll get summation PA as 4,50,000. Similarly, PB, so 6,000 into 20 is 1,20,000. The next one is 60,000. Next is 80,000. Then 1,60,000. So summation PB is equal to 4,20,000. So now let us write the formula for STDR of locality B. Okay, so here I'll write, I'm sorry, it's not locality, it is village. So village B. So write the formula. Consider STDR of B is equal to summation PB by summation P. So therefore STDR of A is 4,50,000 divided by 30,000. So you will get 15, and STDR of B is equal to 4,20,000 divided by 30,000. You will get 14. So the conclusion, so whichever STDR is lesser, that village will be healthier. So since STDR of B is less than STDR of A, village B is healthier. (37) question. Show that Fisher's index number satisfies time reversal test and factor reversal test for the following data. So items are given as ABCD. Then 2019 is the base year. The prices and quantities are given. And 2024 is the current year. The prices and quantities are given. So now let us write the condition for the time reversal test. So subdivision A, to verify Fisher's index number satisfies TRT, that is P01 of F into P10 of F is equal to 1. This will carry 1 mark. Now remember that when we write the formula for P01 of F and P10 of F, we do not multiply by 100 because it should be considered as only a ratio and not expressed in terms of percentage for TRT and FRT. So let us first write the formula for P01 of F. How to remember the formula I have already taught you in my previous videos. So it is last payer's price index number without the 100. So root of summation P1 Q0 by summation P0 Q0. This is last payer's index number without the 100 multiplied by Paget's index number without the 100, that is summation P1 Q1 by summation P0 Q1. Similarly, write the formula for P10 of F, which is root of. So in this formula, if you replace 1 by 0 and 0 by 1, then you will get the formula for P10 of F. So now let us go back to the table and then form the columns which are required. So the columns which you will require are P0 Q0, then you have P1 Q1, then P1 Q0 and P0 Q1. So let us find out P0 Q0. So before that I have to mark the columns correctly. So this is P0, this is Q0, this is P1 and this is Q1. So 10 into 15 is 150, 14 into 20 is 280, then we get 510 and 500. So summation P0 Q0, this is equal to 1440. Next we'll find out P1 Q1. So it is 14 into 25, which will be 350. Next is 20 into 30 is 600, then 675 and 960. So summation P1 Q1, this is equal to, you will get 2585. Next find out P1 Q0. So it is 14 into 15, that is 210, then 20 into 20 is 400, then you have 450 and 750. So summation P1 Q0, this total is equal to 1810. The last column is P0 Q1. So P0 Q1 is 10 into 25 is 250. Then 14 into 30 is 420. Then we get 765 and 640. So summation P0 Q1 is equal to 2075. So now that we have completed all the calculations, let us substitute these totals in these two formulae. So this is equal to root of summation P1 Q0. So 1810 divided by 1440 into 2585 divided by 2075. Similarly, substituting the totals in P10 of f, you will get root of 2075 divided by 2585 into 1440 divided by 1810. So now multiply both. Therefore, P01 of f into P10 of f is equal to, so draw a long square root and write all these 8 totals. So all the totals will get cancelled, and so you will get root of 1, which is equal to 1. So therefore we have P01 of f into P10 of f is equal to 1. So write the conclusion. Therefore, Fisher's index number satisfies TRT. 38A. Calculate the trend values for the following data by 3 yearly moving averages. The years are given and the corresponding sales in thousands are given. So the first step is we will write given M. So M is called as a period of variation. Here it is 3. So it is an odd number. So whenever M is odd, we'll just have 2 columns. First is a 3 yearly moving total, and the second is the 3 yearly moving averages, which are also called as the trend values. So it's a very simple problem. You have to just add 3 values at a time, and write it corresponding to their middlemost year. So add 81, 21 and 20 and you will get 59. So one way is for 3-yearly moving averages, you will see that the first value, that is a trend value, and the last trend value will be missing. So in the beginning itself, you can put a blank for the first and the last trend values. Next, you leave out 81, then add 21, 20 and 16 and write it corresponding to 2002. So you will get 57. Similarly, leave out the first two, add the next three, you will get 53. Then you will get 49. Then you will get 54. Then 57 and 60. Now, 3-yearly moving averages means the previous column it will just divide by 3. So 59 divided by 3, 19.67. The next one is 19. Then 17.67. Then you get 16.33. Then you have 18, 19 and 20. So you see that it is increasing till 19. Then it kind of decreases. Then after 16 it is increasing. So you can write the conclusion. The given time series indicates a fluctuating trend. Subdivision B, for the following time series, fit a linear trend by the method of least squares. So they have given us the years and the production in thousands. So years you mark it as X and production in thousands you mark it as Y. Then we find out summation Y, which is 108. Then you start the problem, write given n is equal to 6, which is even. Then you write, let y equal to a plus bx be the straight line equation. The two normal equations are first one, na plus b summation x is equal to summation y. Second, a summation x plus b summation x square is equal to summation xy, where x is equal to deviation from the arithmetic mean of the two middle years. That means 1988 plus 1999. This we have to divide by 2, whole divided by h by 2. So x is equal to deviation from 1990 divided by h is the difference between the years, which is 4. So 4 divided by 2 is 2. So finally, we get x as deviation from 1990 divided by 2. So in the table we'll form 3 columns, x, x square and xy. Take the first year 1980, subtract it from 1990. So you'll get minus 10. Minus 10 divided by 2 is minus 5. Similarly, take 1984, subtract it from 1990 and then divide by 2, you'll get minus 3. Similarly, minus 1, 1, 3 and 5. Our aim is to make summation x as 0. Next, calculate x square, 25, 9, 1, 1, 9 and 25. So, summation x square is equal to 70. Next, we calculate xy. So, it is 16 into minus 5 is minus 80. Then minus 60, minus 19, 14, 54 and 105. So summation xy is equal to 14. Now substitute in the first normal equation. So you'll get 6a plus b into 0 is equal to 108, or 6a is equal to 108, or a is 108 divided by 6, which is 18. Similarly, in the second normal equation, it is a into 0 plus b into 70 is equal to 14, or 70b is equal to 14, or b is 14 divided by 70, which is 0.2. So therefore, we get the fitted linear trend as yc equal to, in place of a, substitute 18, and in place of b it is 0.2. So you'll get yc is equal to 18 plus 0.2x. Thank you all my subscribers, especially the second PUC students who were referring to all my important videos from various chapters and the 3 model papers which I especially solved this year, along with important and sure questions. Hope all these videos have been really useful to you, and I do hope that you score exceptionally well and many of you score out of out in your board examinations. Kindly do like, subscribe, share and comment on my videos. Thank you so much.